There are a few other Laplace transforms that are worth knowing, just sort of off the top of your head. One is the Laplace transform of 1. So we can calculate this by hand. This is the integral from 0 to infinity of e to the minus st times 1 dt. So the integral from from 0 to infinity of e to the minus st dt. This is 1 minus 1 over s e to the minus st from 0 to infinity. So now we need to plug in our bounds. We get minus 1 over s times e to the minus s times infinity. So again, this infinity, this is really a limit, and we'll think about that limit in just a second, minus e to the 0. Okay, now for this limit, so minus 1 over s, for this limit, if s is positive, then e to the minus st, as t goes to infinity, well, this exponent is going to negative infinity, and so this e to the minus st goes to 0. If s is negative, e to the minus st, right? If s is negative, then this exponent is going to positive infinity, and then e to the minus st goes to infinity. So as has been the case in a few other examples, we have to have s being positive for this to be defined. But if s is positive, then this first exponential is 0, minus 1, and so that means the whole thing is just 1 over s. So the Laplace transform of 1 is 1 over s. All right, so now let's look at the Laplace transform of t to the n for a non-negative integer n. Notice that we've actually done a couple of these already. So the Laplace transform of 1, which we just calculated is 1 over s, that's t to the 0. So that one we already know, it's 1 over s. And the Laplace transform of t to the first, that was one of our very first examples, that came out to be 1 over s squared. Okay, so you can kind of see a pattern forming here. But just to see how the pattern might continue, let's do one more of these. So Laplace transform of t squared. So this will be the integral from 0 to infinity of e to the minus st times t squared dt. And we need to use integration by parts. So doing integration by parts, we get minus 1 over s times e to the minus st times t squared plus integral of 1 from 0 to infinity of 1 over s e to the minus st, and then times the derivative of t squared, so 2t dt. Now this first piece, this is from 0 to infinity. This first piece, if s is bigger than 0, which, it's usually the case. If s is bigger than 0, this first term is 0. So I'll let you work through L'Hopital's rule on your own for that one. So let's work out this remaining piece. So we can move this 1 over s and also this 2 outside. So 2 over s times the integral from 0 to infinity of e to the minus st times t. But this integral we already know, so 2 over s times, this integral is the Laplace transform of t. But we know the Laplace transform of t already. It's 1 over s squared. So we get 2 over s cubed. So that's the Laplace transform of t squared. Now if you look at the pattern here and think about what would happen if we changed this squared here to a cubed, well, what would happen is you do integration by parts once, you'd get a 3 right here, and then the resulting Laplace transform would be the Laplace transform of t squared. And we know t squared, right? We just figured it out. So the upshot of this is to get from one power to the next, you just multiply in the denominator by another factor of s, and in the numerator by the power that you're headed towards. So if you repeatedly do this, your numerator gets first a times 2, and then a times 3, and then a times 4. And so in general, if you go up to t to the n, what's going to show up in the numerator here is n factorial. And you can see in the denominator, every time you increase the power by 1, the denominator gets an extra factor of s, and so you're going to end up with s to the n plus 1. If you want to do a proper mathematical induction to prove this formula, that's entirely possible. One thing that we don't know at this point is, how does this work out if your exponent is not a non-negative integer? What if it's negative, or what if it's a fraction? Well, the short answer is we don't know. When I say we, I mean you and me. Humanity knows. It is possible to work out what the appropriate formula is if your exponent is not a non-negative integer, but we're not going to worry about that right now. Okay, one other common function that people need to know the Laplace transform of is sine. So what if we take the Laplace transform of sine kt? So this is the integral from 0 to infinity. This is something you can work out for yourself. You might run into a nasty integral that you need to use an integral table for, but if you're up for the challenge, go for it. So integral from 0 to infinity of e to the minus st sine kt dt. And you might have run into this kind of integral before, sine or cosine times an exponential. And it's sort of a classic case of integration by parts to figure out what this integral is. You do integration by parts twice, you get a big awful equation where this whole integral shows up as an unknown, and you solve that equation for this whole integral. I won't do that. I'll just sort of look up the answer for what you get, because I've done it in my life enough times that I don't feel obligated to work it out by hand. But what you get is, so this is the sort of thing that you could just look up in an integral table in the back of any calculus textbook. You get e to the minus st over s squared plus k squared times s times sine kt minus minus k cosine kt. And this needs to be evaluated from 0 to infinity. Okay, so let's simplify this. So e to the minus st over s squared plus k squared. When we evaluate this at when we take the limit as t goes to plus infinity, first of all, for this exponential to not blow up to infinity, we need s to be positive, so that's no huge surprise. And when that happens, this goes to 0. So, right, it doesn't matter what's in the brackets because this thing in front is going to 0. Okay, so now let's plug in 0 for t. When t is 0, this numerator turns into 1, so 1 over s squared plus k squared times, now we need to work out the stuff in parentheses here, so t is 0, sine of 0 is 0, so 0 minus k times, and cosine of 0 is 1. So we get, right, minus and minus is plus, in the numerator we get a k, so k over s squared plus k squared. So this is the Laplace transform of sine kt. All right. It's worth looking up or working out the Laplace transform of cosine kt. Of course, that's going to be another common one, but I'll let you work that one out for yourself.